A good morning to you all. This is Watala Alexander Mark, and we are Group 30. Before we start our presentation of our idea, let's start by introducing ourselves. So let some of the members of the group start by introducing themselves, then I continue with the presentation.
All right. Good morning. My name is Muinza Sophia. Welcome to our YouTube channel. This is Group 30. I'll be responsible for troubleshooting and networking. I think let me hand over to Kavuma.
Good morning, everyone.
Good morning.
Good morning, everyone.
Good morning.
I'm Kauma. Good morning, everyone. I'm Kauma Joseph, and I'm responsible for coding. Yeah, this is our YouTube channel. You're welcome, everyone. And then we'll continue with our presentation.
All right.
A good morning to you all once again. Welcome to our YouTube channel. Let's start with presenting our idea. This is the title of our project, Micro Drone with Proximity Alert System using Lidar.
Yes.
Then our problem under investigation, you realize the major problem associated with drones is that they need a lot of clear space to fly and cannot be flown in tight places such as dense forests or areas with many trees and tall buildings, due to a high risk of collision and damage while flying. Furthermore, drones are generally costly in purchase, and that is why drones are still not a very common gadget. The background of our study: historical facts and data gathered over the years states that in large cities like Sao Paulo, people die more of traffic crashes than natural causes. Some of the road accidents happen due to the driver's inability to recognize objects around them. This recognition can be done by lidar sensors before collision with the objects. Currently in Uganda, drones would have helped us in various fields such as game reserves, whereby they would be used to capture and track data, for example, getting the population of species of animals, but due to lack of enough clear space to fly, the drone hasn't been implemented. And also due to the cost of UAVs, unarmed aerial vehicles, drones. Drones are still not a common gadget in Uganda. The significance of our study: our findings deepen the current understanding about lidar technology in UAVs, whereby collision of drones with obstacles can be limited, and also provide access to cheap and affordable working prototypes of UAVs made with the available resources with light design. Slide 5 talks about our project scope. The project aims at producing a working prototype UAV with the available resources for demonstration. The drone should be able to detect obstacles using the lidar system. We expect to acquire more knowledge and insight into the advancement of drone and other advanced technologies that require elements of computer science like artificial intelligence and hardware programming. Limitations of the project are as follows. Drone has limited operating range. It does not auto-avoid obstacles and also limited battery life. Let's go to our problem statement. Drones need a lot of clear space to fly and cannot be flown in tight places such as dense forests, tall buildings, or indoors due to huge risk of flying. So this is our problem statement. Next is our hypothesis. Using the lidar technology on drones will reduce the number of collisions of drones with obstacles. With this lidar technology, drones will be able to detect obstacles within air and determine the proximity. The drones will be at a low cost due to small size and weight, thus making them a common gadget. Next slide talks about our methodology. In order to achieve the specified objectives, as stated above, various means are to be employed. For example, system requirements are to be obtained through different data collection techniques. And in this case, we shall study the available UAV technologies through document reviews to acquire background information about UAV technologies and its uses in the real world. Feasibility studies to find what it takes in terms of resources, skills, and time required to undertake the project. And observation to identify how successful Lidar technology has been applied to obstacle detection. Interrelations and data flow diagrams will aid in the system design in order to modulate the complexity of the system. The system will also utilize many software and hardware components during its development phase, of which then will finally be tested to see if their intentions. For the software, firmware programming will be done. Low-level programming languages such as C and C++ will be used. And for high-level programming of the drone, Java and Python will be used. That's our block diagram, the motors and the Lidar module. Research objectives: build a micro drone that can detect obstacles within the air and determine the proximity of the obstacle so as to avoid collision. To build a drone with radar and buzzer indications per obstacle. To build a small size, lightweight, and low-cost drone. To produce a working model prototype UAV for research and study. Next slide talks about the proposed research timeline. Below are the tasks, start date, and duration. Requirements gathering of equipment. It will start from 14th February 2023, and it will take 19 days. Then assembling hardware, 13 days. Firmware programming, 14 days. Application programming, 26. Drone testing, then the presentation. Research questions. What is the benefit case of using the Lidar technology from logical and economical perspective? What does drone Lidar measure? What can drone Lidar be used for? How much data does drone Lidar generate? Where can you fly the drone? How do I access drone data? These are the research questions we shall be answering. References: Laser Systems and Applications by Chondri. Full Control Quadrupter Intelligent Robots and Systems by S. Baudala. Thanks for watching. This marks the end of our presentation. Yeah.